Okay, cool. There we go. So let me just pull up my screen. Hopefully I can actually share it. Maybe I should have tested this first before I started recording. Okay, so everyone can see my screen, right? Awesome. So I think I actually have the code open here. So yeah, hi, welcome. This is my little talk on the Kirby and the Amazing Mirror randomizer that I've been building. It's a very work in progress project. Um, yeah, definitely kind of embarrassed to be even presenting this because I wouldn't say what I have here is particularly amazing. I've definitely learned a lot of lessons along the way. And for a bit of additional background, I actually am not a web developer in any capacity. I've never done any like, real web development before. So this is my first real web application that I've ever made. So you'll see a lot of things that went wrong and how I've been kind of trying to fix them and move away from certain things. But yeah, so this is the randomizer. If you don't know what a randomizer is, well, the name is sort of self-explanatory, but randomizers for video games are typically tools that change certain elements of a game. Usually it's a game that doesn't have so many randomized elements to it, and it just kind of swaps those bits around. So a very, I guess, popular one is a link to the past randomizer. So there's this nice little web application here where you can basically upload a ROM file for a link to the past, and you can like choose some options and then like click a button. It'll basically upload your ROM file there. It has to be like a base vanilla ROM. Obviously, they can't be distributing ROMs because that's kind of illegal. But yeah, after that, it pokes some values in the ROM, and then it lets you download it afterwards and start playing. So I'm not actually going to be showing any of, I guess, the actual playing because that means I'd have to get an emulator and I'd have to like upload the ROM and stuff like that. Basically, in terms of like legality, distributing ROMs is illegal, right? If you happen to, extract the ROM from a game yourself, that's fair game, right? If you've managed to do it yourself. But otherwise, like distributing ROM files is illegal. So that's why these randomizers they're able to operate based on the fact that they just take some file, they poke some values, and then they basically redistribute that modified file. So you're the one who has to actually provide the base ROM. So given that you have the ROM, then you can play the randomizer. So that's the gist of this. Kirby and the Amazing Mirror is a very different kind of game. It's another Nintendo game, as you can probably imagine from the title. But this one is for the Game Boy Advance instead of the Super Nintendo. As far as I know, no one else has done anything like this before. No one else has randomized this particular game. I haven't really dug around too much recently, but yeah, this was actually fairly difficult to randomize for a number of reasons. But yeah, I decided to give this a try. Most randomizers seem to be written in like PHP or like Python. I decided I think Rust is perfectly suitable for this. Why not give Rust a go? And so we'll see how that went and where things are going. I guess first of all, I want to talk about what I got up here. So on the main branch, this is sort of like my primary development branch, and I've kind of organized the project into like multiple like feature branches. The original design that I had for this was actually pretty object oriented, which I ultimately kind of ended up slowly like moving away from over time. I had just literally gotten off of a work project that was designed in like a very top down way with like interfaces kind of laid out in like a hierarchy, very typical object-oriented architecture, and that's really how I started this project as well. But the way that traits work kind of encourages a sort of different design, I would say. I'll get into that in a moment. But essentially, I started with a front end and a back end, and it was supposed to be like an SPA. I introduced like a bunch of JavaScript in here. This is actually pure script code, so you'll see like this stuff is very not Rust. It's not very JavaScript either. And over time, I kind of ended up disliking this code a lot. It wasn't really doing a whole lot for me, and I kind of wanted to go for server-side rendering instead. So that's why, while this is still here, the main branch that I'm working on right now is this remove pure script branch. And so this is a lot cleaner, but there's still some old, I guess, vestigial code, like this build and run script that calls the pure script package manager and stuff. So yeah, the bulk of the Rust code actually is here in this backend folder. And I'm just going to start by tackling this from the main module here. So the application is a Rocket application. Let me just try and boost the... oh, how do you zoom in a bit? There we go. Yeah, so this web app is written using Rocket. So the reason why I picked Rocket is, well, honestly, I don't really have a good reason. I just kind of wanted to build a web app, and I didn't really know what to use. There were like so many different frameworks, and I just sort of picked one at random. And yeah, Rocket was at the time, they had a new release candidate for 0.5, so I was like, sure, I'll pick that, and I'll just update to 0.5 when that comes out. That was several months ago, and they haven't updated, or they haven't released 0.5 yet. So yeah, I think maybe that wasn't the best choice, but I have to quickly switch tabs here so I can...
Yeah, actually, I also decided comparing Rocket versus Actix Web. So I think Actix is more popular and more supported in community. That's why I choose from my side Actix Web.
Okay, yeah, that's probably a good choice. I know Actix is faster, I think. I remember there was some like community drama around Actix and the usages of unsafe in it. So yeah, I don't know. I picked Rocket just kind of at random, but if I were to go back and make a different decision, yeah, maybe I would have used Actix instead. I guess it's not too late right now. The project is still relatively small, but anyway. So let me just go to the main logic here. So yeah, this is the starting point for a Rocket app. I basically just copied a lot of this out of examples that they provided in the Rocket repo, except for this. Actually, yeah, I guess this is sort of also in there, managing some sort of state in the server. This state isn't really state though. It's just like I wanted to load the actual ROM data right at the start when I first boot up the server, because I don't need to keep rereading from that ROM file every single time I want to make a request to the server. It seems kind of a or not, sorry, not the ROM file. That would imply that I actually have the ROM. This is actually data that tells the randomizer which values in the ROM file need to be changed. So yeah, I didn't want to keep having to reload that all the time. So that's why I have this little environment variable that you set, and that just kind of says, here's where that data is. So that's loaded up in this method right here. But the actual meat of the logic is here. Looks like the indenting is kind of messed up. I think I may have accidentally let some tabs sneak in, so that kind of sucks. I should have run Rust format. That's another thing. If you're new to Rust and you're not aware, Rust format or Rust FMT is really, really useful for just automatically formatting your code. Similar to like Go format and other similar tools in other languages. But I find it quite nice because it's easy to enforce a single styling that way. But obviously, opinions will vary on whether or not that's actually a good thing. So yeah, so I got a couple of routes here. This index one is just the initial one that loads. It just loads the index.html. And then I have this for submitting a form. And this is where the bulk of the logic is. You'll notice I'm using a lot of print lines here. These are probably going to be removed. This was for debugging, and I didn't have a logger yet. I still don't have a logger yet, I should say. I've been thinking of using tracing because I've heard that tracing is a very good option for that. But yeah, I'm actually still kind of looking around, so I'm not really sure what I'm going to be like committing to yet in terms of logging solutions. If you have any suggestions, then yeah, I'm definitely welcome to that. But yeah, basically this just takes the form. The way that Rocket works is that you can kind of define your form data as like a struct and then implement like this from form trait. You can actually just do a derive for it, which is kind of nice. And yeah, it kind of when you submit the form data, it actually tries to parse it, and if it doesn't parse properly, then it'll return a none, and it'll end up in this case down here. But if it does parse successfully, then it ends up here, and then it'll actually run everything. So that's kind of nice. They have like a bunch of derive macros and other nice, I guess, annotations that you can use to kind of make it more strict, I guess, about how it validates and parses the form data. Yeah, that actually caused a few issues for me, because when it does fail to parse, it can be pretty hard to figure out like what's going on. At least from the error messages, like it just returns like a 422, and yeah, I had a lot of trouble trying to figure out what was actually going wrong with the form parsing, especially if you're using like this contextual thing. Like they're like the way that they have their forms validated is in sort of two steps. They have it happening on like the client side, which you kind of have to specify using like your templating engine, and then you also have the server side validation. And so whenever stuff screws up on the server side, it's like, oh my god, what's going wrong? Yeah, I'm not really sure what the best way to debug those issues is. I ended up just kind of commenting stuff out and poking around at it using different values. I think they also have like a Rocket client that you can use for testing, and I probably should have used that. But yeah, I kind of wanted to get something going pretty quick just for this demo. So anyway, once we get the form, we call run randomizer. And here's kind of where a lot of the high level logic is. So first we need to take that ROM file from the submission and we save it to the system temporarily. We try to open it with these open options. So this gives like read permissions, this gives write permissions, and we construct a configuration from the submission. So that specifies things like what kind of randomization do you want, what seed do you want. So yeah, we get the seed from the config here. Seeds are pretty important in randomizers because if you want to share like a certain like randomized configuration of a game with someone else, then the easiest way to do that is to actually just share the seed with them, and then they can plug that into the randomizer and get the exact same game that you played, and then you can kind of, you know, share with your friends your experiences and stuff. And that's also useful for like tournaments where people do races and stuff. I don't think that people are gonna be doing that with this randomizer in particular, but it's always nice to just have the option. Right, so I create this ROM file struct here. We clone this graph. Oh yeah, this graph is constructed when we load the game data initially on start. I'll get into that a little bit later. That's kind of more nitty-gritty details. And then we call this randomizer randomize katam function. And then after that, we just add this header and return this randomized ROM responder. So the way that you customize responses that Rocket sends back is by implementing this trait called the responder trait, and it's basically just like if you're not familiar with Rust's traits, you can kind of think of them as being like your typical I guess Java interface. So I have an implementation for this like form response that kind of contains like all the template status and the randomized ROM. But like the randomized ROM itself has to also be something that implements responder as well. Otherwise, I can't store it there. Yeah, and you can see like I actually just commented this out for now. The code base is kind of in a bit of a messy state right now. But yeah, that's kind of the nature of this very work in progress project. So yeah. So let's get into the main logic of the randomizer now. Where is it? No, not there. Oh, that's too far. Okay, yes, here. So basically the first thing that I do is I just check the configuration file to see what kind of entrance shuffling what was specified in the user options. This is not the only option that will probably be available at the end of the day. So I know other randomizers like to add things like enemizers where you can like swap the locations of enemies in the game. So that would be like another option that would be loaded into the config. Usually there's also like a bunch of cosmetic changes you can make too. So that's another configuration option that could be added. But basically this just kind of takes the config, processes the configuration options, and then calls like the actual shuffler algorithm. This chaos shuffle isn't implemented at all, so this doesn't actually do anything right now, but the standard shuffle is implemented and it does work. After it finishes shuffling everything, it calls a rom.write data here. This just writes the shuffled data back to the ROM based on the now mixed up graph. And yeah, that's pretty much all there is to this. It's actually incredibly simple. There's not too much code to this at all. So yeah, I guess first of all, I want to get into the standard shuffle stuff, but before I do that, I just want to ask if anyone has any questions so far. Like, is this making any sense, or am I just kind of flapping about and this is very confusing for people? Let me just check. I'm going to assume that we don't have any questions so far. So I'm just going to keep moving on here. So yeah, here's the standard shuffle. You'll notice that this RNG is actually a mutable reference to this generic argument here, which it has to implement the random bool and choose multiple fill traits. So those traits are traits that I defined, which are just like a very thin layer over top of the rand crate. It's a pretty popular crate for, getting random numbers. Originally, this was actually a RNG trait, and it was just like one big RNG trait. Well, I guess not big. It was only two methods, but when I added choose multiple fill, I kind of decided that maybe I didn't want to actually keep everything in one RNG trait, because the more methods you add to your traits, similar to like interfaces in Java, the more like you have to, it affects all of your implementations. Like traits and interfaces don't exactly scale that way. Traits in general, I don't think are supposed to be used or they're not supposed to really be used to abstract over objects in that interfacey kind of way. I guess you could argue that you could do that in Java as well, but the name trait is kind of more indicative of abstraction over behaviors, and so that's kind of what I opted for here. I feel like it's a little bit more idiomatic. It's more in line with your usual like hash, equality, debug, all those other common standard library traits. So yeah, that's the RNG graph. So the entire game is basically a bunch of rooms with doors leading from one room to another. You can think of it as like a big maze, essentially. And so the way that I represent the game in my code is as a graph. So I actually abstracted over the graph, and then we created this graph trait. I'm not sure I really like it, but yeah, it's okay. I think the original intention I had was to swap it out for like another implementation. Currently, the actual concrete implementation of graph that I'm using is using pet graph, and there are some things about the pet graph API that I didn't like at first. I've kind of come around to it over time, but yeah, at first I was thinking of doing something, just kind of like rolling my own solution, and so I kind of decided to abstract over that in case I actually wanted to commit to that. But over time, I think I've realized that what I have is probably fine, and I'm not likely to change it. Oh, wow. So the first thing that we do in the shuffler is we actually check, is the game currently beatable to begin with? Because that's kind of the core assumption that we have here as we make modifications to it. So if it's not beatable, we actually just panic here. And I think that's a pretty reasonable thing to do in this case. If the initial graph isn't beatable, something is very clearly wrong with the data that we loaded. And so panicking and killing the server, not the worst thing we could possibly do, I would say, especially because everybody who would be trying to use the randomizer would have would be getting bad, I guess, randomized games back, and the games wouldn't be beatable, and they'd probably be very upset. So I think this is I feel like this was the right choice here. I don't know. Yeah, so we actually try to modify the graph 100 times, and that's hard coded here. I want to make this configurable, but I haven't gotten around to it. And yeah, here's the actual algorithm itself. It's very simple. First, we pick a couple of random edges from the graph, and then we try to swap those edges with each other. And if we find that the graph or the game isn't beatable after we've swapped them, then we just swap them back. And that's pretty much it. It's a very simple algorithm. It obviously has some problems in that, if we only try it like so many times, we might not randomize certain parts of the graph. There we go. I did click admit, right? Do we have more people here? Yes. Okay, cool. But anyway, yeah. So there are some flaws with this algorithm. It kind of sucks. But at the very least, it doesn't produce a game that isn't completable. Or at least in theory, it shouldn't. So yeah, that's the shuffler. I'm gonna now dig into the next step here. Actually, did I? Oh wait, no, I did talk about right. The writing back to the ROM doesn't happen at this level. It happens at the level above, back in main. That's right. Okay. Oh, I should also mention, I actually forgot. The way that we check that the game is beatable is we actually use I think it's Tarjan's algorithm to find like strongly connected components. It's just part of petgraph, and if I can find the implementation of this, then yeah, that should be in here. Yeah, this is where the bulk of the code is, honestly. Let's see, is it in here? Let's see. What would it be? Full graph. Yeah, get unreachable regions is what we use. Yeah, there's like a condensation algorithm that you can call, which uses like Tarjan's algorithm under the hood and gets all the strongly connected components. We check that every strongly connected component has like at least one edge going to it. And for the ones that don't, we just return those. I just wanted to actually get the regions that aren't reachable because it's actually really nice for debugging. I've had multiple scenarios where I tried to do this with just like a Boolean, and I wasn't able to actually get enough debugging information to fix the problem. So I eventually ended up having to do this like vector of regions, and it actually ended up working pretty well. Of course, the only reason why that was happening to begin with is because I actually screwed up during data entry. So yeah, data entry was very, very error prone, I will say. So yeah, let's get into the actual game graph part here. So first, I want to just talk a little bit about how I've kind of organized things here. So the main graph trait just has these four operations. It has the ability to swap edges, and you can pick random edges. You can get the edges. This is actually kind of this is just for the ROM. Actually, is that? Oh wait, no, never mind. I had an idea for something a while back, and I thought I'd implemented it, but no, I didn't. uh, and yeah, and get unreachable regions. Um, I also have this door data trait here, which is separate from this. This originally was going to be part of the graph trait, and I ended up realizing that it's kind of not really related to like what a graph does. So the door data trait is for getting the data that we loaded in initially from our. I didn't talk about that file. Yeah. Okay. There's so many things I want to talk about that I'm kind of I'm not really like super organized about here because I didn't really have like a huge amount of time to prepare this. I'm sorry. So let me take a step back here actually. So in the source, I think. No, not in the source. Where it's right here actually. So this is the actual data that I'm loading in at the start of the randomizer. And these hex values basically indicate where each door leads to and which addresses you have to overwrite to make that door lead to um, the corresponding destination that it normally goes to. So basically what the randomizer does at a low level is it actually copies like these values over these hex addresses in the ROM file, and that's how it basically moves the pointer from one door to like a different exit. It's kind of interesting. Yeah, this file is actually pretty big. There's a lot of data in it. That's why data entry was so error prone. Yeah, and these are the actual edges. Yeah, it's pretty nasty. You're probably wondering why I'm using this RON format instead of regular JSON or something else. I actually didn't want to use RON to begin with. I actually wasn't even thinking about RON at all. This was all JSON at one point, and I started running into problems when I was entering in these like hexadecimal literals because you can't use this notation in JSON. For example, if I wanted to put in like 0xAB, I'd actually have to write in like 171 or something, right? Like it wasn't really nice going from like a hex editor to decimal values that I have to punch in here. So I ended up using RON because it just lets me copy and paste the values and not have to think about conversions to decimal or anything like that. Yeah, so that was fun converting this from JSON into RON. Thank God for Vim macros is all I have to say about that. But yeah, I'm not sure if this is the best representation for the data, to be honest. It's basically like a big JSON document split into like three major components. Like I have this door data mapping, which has these like string IDs mapped to these, I guess, destination bytes and the addresses that need to be overwritten. Oh God. Yeah, that's fine. Okay. And there's also the, why am I scrolling? This thing's huge. Yeah, there's the static edges. So static edges are basically edges of the graph that won't be changing. since the game is kind of split into these different rooms, when you enter a door, you're kind of transitioning from one room to another. So there's kind of an edge between the rooms, but being able to describe constraints of like, can I reach one part of a room from another part of the room? Describing those constraints is kind of separate from describing the actual edges connecting two different rooms. So I have this notion of static edges to encode, yeah, the internal to a room edges, and I found that that was a very nice way of representing that. It made the logic a lot simpler. So of course, I don't just have these static edges, I also have these dynamic edges. As I mentioned before, these are the ones that go between rooms. And these are the ones that will get randomized. So yeah, that's pretty much how the I don't really know what to call this. I just call this the door data. This is how the door data is laid out. String IDs are mostly being used here for human readability. It makes it easier for me to debug things. I could have used integer IDs, and at one point I was, but I found that just extremely error prone when I was trying to enter data into this file. I think if I were to change this, I'd probably actually have like a tool with like a UI where I could kind of enter in the data more easily so that I don't have to use string IDs everywhere. And then I don't have to actually manually edit this this file. But given that I don't have said tool, this felt like the most pragmatic choice. I don't know. And let's see here. Yeah. Oh, do we have a question? All right, no problem. We're just gonna continue moving on. So yeah, the game graph. This is where the vast majority of the code is. This ended up being way more complicated than I ever thought it would be, just because of how, I guess, low level pet graph is. I mean, obviously, pet graph is trying to be a very efficient library. It stores everything with like indexes and stuff like that. My original idea was to just kind of use like an immutable graph and just kind of copy that over and over again, but yeah, kind of a lot slower. So I didn't end up going with that. I don't really want to get too into all this code because it is quite low level, but yeah, you can see just the sheer amount of stuff that had to go into this to make this work is yeah. I mean, I guess it's not really that big of a file at the end of the day. I did try to trim down the logic here a lot and try to make it as clean as possible, but yeah, there were a lot of places where it wasn't really that feasible. So yeah, rather than dive into that, I think I'm just going to move on. The RNG implementation is here. Pretty standard stuff. I tried to keep these implementations very small. So it's just a very thin layer over the brand library. I'm generally pretty happy with this, I think. At the very least, if you want to play the code coverage game for testing, this works pretty well. But yeah, I mean, could have combined these into one trait, could have decided to, or could leave them the way they are right now, as it is with two different traits. I kind of like the two different traits because it feels more idiomatic, like I said earlier. One thing I want to talk about is the organization of my modules. Originally, when I was implementing this, I had like a ton of module cycles, and that really sucked. And so over time, I came to realize that the best way to organize your modules in Rust is to kind of keep your types and traits in their own module like this. Well, maybe not all your types. I mean, obviously for your concrete implementations, they should go in their own module. But yeah, you'll notice I define my trait graph here. Here's like another trait. I put my error types in here as well. You could also split those into a separate error module as well. I think that would also be pretty reasonable to just like have a folder for like all the graph related modules, including an error module for each of those folders. But I felt like I didn't really have enough code to justify that, so kind of keeping it relatively flat here feels nice. But yeah, the actual implementations, they all have their own modules, and this is where I define like the actual concrete types. So I think I have like game graph here. Yeah. And the trait impulse also live in these modules as well. What's nice about this is that it lets me basically reuse this code, or not this code specifically, but the traits and stuff like that as like library code. Kind of keeps things nice and separated. Yeah, and my idea for this, I guess, structure came from a talk from, I think, RustConf 2018. I think it was called No Spaghetti. And yeah, after following that design, I realized that, yeah, that's actually really good. That actually works pretty darn well. So yeah, this is most of what I've got here. Okay, the last thing I want to talk about is just this ROM module. So yeah, I have this ROM trait, which basically describes like how to write data to the actual ROM file. There's a lot of constraints here. Thankfully, yeah, the complicated constraints are only really relegated to this like one method. And go into the implementation as well. So, okay, let's see. Oh yeah, so I actually have like a couple of layers here. I actually added like this ROM read and ROM write traits. These are in the implementation module itself because I kind of wanted to unit test the actual byte writing code. So I actually have some unit tests down here. Like these are like the only real unit tests I have in my code base so far, which is not great, but I will be adding more tests soon. So yeah, that's why I have this extra thin layer over the file reading and writing operations here. But yeah, the bulk of the logic is in write data. You get the graph edges, and we basically do the swap that I mentioned earlier when I was going over the RON file. So after all that is done, we just write it back to the to the file. And I guess the one thing I will say about this code is that I ended up needing to accumulate errors, and in Rust, that's not like the cleanest, simplest thing to do. Is what I realized. There were actually some nice libraries out there that let you do sort of like a Haskell applicative functor kind of thing to collect your errors in a very like nice and clean way. But I kind of I actually did use one of them at first. I think it's called like validated or something. But yeah, I kind of didn't really like all the extra dependencies I was pulling into the project. So at some point I started chopping dependencies out of the project, and that had to go as well. And ultimately what I ended up with isn't a lot worse, I would say. I have these like extra little if errors not empty, then return like all the errors in this like error type that I kind of wrap it up in. But I don't know. I don't think this is actually that bad. It's just a little bit more complicated than it would ideally be, I guess. So yeah, that's pretty much everything. Oh, one thing I guess I could mention is that I also am using this error for defining errors. I'm actually not using anyhow at all in this Rocket application, which I was kind of surprised by, because when I started, I was like, okay, I'm writing an application, and applications are generally consumers of errors, right? They do like error reporting and stuff, but because Rocket ends up doing all the error reporting itself, pretty much, I didn't really find anyhow useful. So I actually did put error anyhow into this project to begin with, and then over time I realized I just wasn't using it, and so I scrapped it. And now all my errors are just defined using this error, and that's pretty much it. So yeah, that was kind of I guess an interesting revelation for me as I was working on the project. So yeah, I think without further ado, I'll actually try and demo this project now. I'm not going to play the game because I don't have an emulator for it or anything like that, and I don't really want to be like downloading emulators on like my work machine and stuff. So yeah, I'm going to show basically just running the web server. So it's very simple. I just use this cargo run. You can see it does a bit of, well, print lining. I don't want to exactly call it logging, but yeah, this is stuff that it loads up from the RON file at the start. And now it's started that URL. And so now, if I want, I can enter a seed. So I can give it like, I don't know, 798 as the seed. And then I can give it, let's see. I'm going to edit all this stuff out. That just sucks. Rando stuff. There it is. So yeah, I have like a GBA file here. It may or may not be the real ROM. And then you just click submit. And if all goes well, then yeah, it randomizes it and then it downloads it. And yeah, you can just pop that into your emulator and you can start playing it. So that's pretty much the entire flow. Obviously, as you can see, I don't have the standard and chaos shuffle options here. They're supposed to be in there, but I was having issues with the form validation and parsing. Like I was saying earlier, it's actually pretty painful when you get errors happening on the server side in a Rocket application. It's very difficult to debug the actual like cause of the parsing errors. So yeah, that kind of sucked. I'm not gonna lie. And if you want, you can see I have templates here. These are just Terra templates. This is what it looks like for the index file. Basically modified versions of the example Terra templates provided by Rocket. So this actually this macros file is pretty much exactly the same as the one that they provide. That success one, and I'm not even using the success one right now. So yeah, that's pretty much it. Do we have any questions about I guess anything about this project, or we just flip back?
No, not really, but it was a pretty cool project. I liked it.
All right. Yeah, thanks.
Do you work in web development? Where did you come up with the like the theme and why randomizing a ROM and that sort of stuff. So
No, I'm not a web developer at all. I only do like data connectors and stuff. Like that's my job. This was my first web app ever, so that's why I figured this would be kind of interesting as like a beginner talk, just to kind of relay some of my experiences as like a beginner web developer. Yeah, I actually have no experience doing web development, and this is my first time doing it, and I've definitely learned a lot about how it works, and I've gotten some feedback before as well, like around things like introducing JavaScript into the project. Like I removed all that pure script code because it was kind of suggested to me that adding JavaScript kind of adds more problems to your project, especially if you don't need it. Like the less JavaScript that you can include in your project, the better, especially for things like accessibility and whatnot. And server-side rendering is better for like SEO. So yeah, I tried to keep it very lean on like the JavaScript side, and I managed to eliminate all of it because my application is just that simple. So I think that was actually a pretty good suggestion.
Yeah. Oh, that was pretty neat. I liked it.
Cool. So if there aren't any other questions about this, I'm just going to flip over to the usual news segment. I don't really have a ton of news stories this time because I've been pretty busy lately, but I did pick out a couple of things that I thought were pretty cool. So there's the Rust compiler ambitions blog post. This one's
I
pretty
saw
cool.
that. That was pretty cool. Yeah, it was.
Yeah, there's a lot of really interesting initiatives. I'm still personally looking forward to more of the expressiveness initiatives being fulfilled, I guess, especially around like const generics and GATs. I think that would be pretty helpful. But yeah, like definitely take a look at this if you haven't already looked at it. There's a lot of really cool projects, especially if you're interested in contributing to Rust, like the compiler itself. Yeah, it's kind of a nice roundup of everything that's going on. So, yeah, very cool story. And the other story that I picked up was about Rust 1.59 being released. I always pick out these ones whenever there's a new release. So, yeah. Inline assembly now seems to be supported. For some reason, I thought that Rust had supported inline assembly for like a very long time, but I guess it was only like a nightly feature. So yeah, it sounds like it's actually being stabilized now. So that's pretty cool. They added these structuring arguments, so you can do some very Python kind of things, I guess. I don't know. I think it'll be useful in some cases, but for me, I don't feel like it was super necessary, or at least I don't know. I haven't really found myself needing to use this feature.
For web development, it's pretty useful. In like you build a backend server, for example, you're always wrangling data here and there and here and there. So being able to just use the dot dot operator just means everything else is pretty useful. Yeah.
Yeah. Okay. I think that's fair. Yeah.
Yeah, I guess you're right. It depends a lot on like what you're applying the stuff to, but yeah.
Yeah, I guess I just haven't really like run into any scenarios where I needed the dot dot operator yet, and that's probably
Right,
because
yeah.
my code base is still pretty small. So
Right.
They got const generic defaults now, interleaving. Always good to see more progress on this front. I'm still waiting for like complex expressions at like the type level to be stabilized. I know they have it implemented. I know that it is available in Nightly. I have played with it, but yeah, there's still a lot of compiler bugs around that. So, Man, I don't even remember this. Cargo report. Okay. Sounds useful. Oh yeah, and stripping binaries. Yeah, I remember always having to like manually run strip on Rust binaries, and it's nice that there's now options to kind of do this automatically. And yeah, they turned off incremental compilation again. They seem to be doing this a lot. I don't know like what's going on there. There's always bugs and breakages around incremental compilation, but yeah. It's kind of interesting to see. Unfortunately, I don't really know much about why that happens, but yeah, that's pretty much it. Oh, and there's some other new stabilized APIs and stuff. Actually, no, there's nothing new. There's literally nothing listed here. Okay. Cool. So yeah, that's today's meetup pretty much. I don't really have anything else. Oh, it's just two of us.
That's fine. That's okay.
Well, if there's anything you want to chat about, then yeah, feel free to ask questions or chat about it now. But otherwise, yeah, this is pretty much the end of the meetup, I guess.
Yeah, no, I actually have to split in a couple of minutes, but this is actually the second one I joined. I joined another one, but I couldn't stay until the end, and I'm definitely going to try to participate more in these events because I think they're pretty cool. I think the Rust community needs this sort of thing, and a lot of the complaints that I see people either mentioning on their YouTube videos or just looking through the web is that uh, it, there are plenty of learn how to program in Rust kind of thing, but there are not enough maybe stuff showing you either how to do stuff or places where you can discuss these sorts of things like in the level of detail that you just shared. Right? It's not that trivial to show this type of stuff, and it requires a little bit of knowledge of how the language works to actually be able to either suggest something on the code and that sort of thing. So I think these meetings are quite important, right?
Yeah, I don't know. I got a lot of feedback from the survey I did about showing more like code walkthroughs, showing more work in progress projects. So
Right,
that's
yeah.
kind of why I was aiming for something like that today.
Hmm.
Obviously, it didn't really lead to as good of a turnout as I was hoping for, but I hope that it was at least somewhat useful to someone out there.
It was for me at least. I can't say for the other ones, but I'm always eager to look at other people's code and see like how they code. I find it interesting how it changes, right, from one person to another one. Even though we all try to stick to the same, basic principles while programming, it's interesting to see how people solve different problems. And I think that's one of the things that people maybe meant when they mentioned to you that they want to see more walkthroughs and that sort of stuff, is that there is this curiosity in general, right? Especially with Rust, since coding in Rust does lead to somewhat, as you mentioned right at the beginning of the meetup today, like does lead to quite some different. It leads to a different way of thinking how you're going to structure your code and that sort of thing, right? So I think maybe that's what people are mostly curious about, right? Okay, I'm changing, but they're changing all to like unknown grounds, right? Nobody really knows or have that strong of a community so that you can look at thousands of examples online and say, okay, so this is how everyone does it, right? And it's at least that was the case for me, right? It wasn't as clear as. So you kind of, I think every Rust programmer goes into this, right? It just goes, right? Starts doing
Mhm.
stuff, and like today you showed me your code. It was very interesting to see, how you use more generics than I do, for example, but it works, it works the same because eventually Rust boils down to the same thing, safety and all that and all that. If the code compiles, it works and all that sort of stuff. But it's interesting to see, because that's a new technique maybe that I can use, or something that you did might apply to some specific problem. And I mean, I like it.
Yeah, I mean, it is nice that Rust kind of gives you these like basic guarantees about like memory safety and like null safety, that sort of thing. I definitely like that, and it doesn't really matter like whose code base you look at. Like baseline, it already has all those things. Well, generally speaking, unless they dabble in unsafe. But
yeah.
I guess
That's
one thing I didn't mention is that the entire code base is in safe Rust. Woo! What a surprise.
yeah, exactly. Yeah. But anyway, it was pretty cool of a project.
Yeah, thank you.
All right. Okay, I guess that's it. I'm gonna go now.
All right, cool. Well, thank you for coming, and I hope to see you at future meetups if you do decide to show up.
Oh yeah, no, I'm definitely gonna. Yeah, no, I'm definitely gonna try to join more. I before the last one that I went, then I had like responded to a couple, but I never really got to attend to the meeting. So it's a slow process. So now that I'm here, I've engaged more. I might have more incentives next time because we've chatted a little bit. Maybe we can deepen the conversation, and then it goes.
All right, cool.
All right.
Well, I
All
won't
right.
keep you. So take care. Have a nice day.
No worries. Thank you for the talk, and thank you for the space. All right.
All right, bye.
Bye.